Java is like many programming languages. It's called a strongly typed language. Now, what that means is that when we create things like variables, for example, we have to write a formal variable declaration statement. Now, we're doing two things when we declare a variable. The first thing is we're giving it a name. That name is called the variable's identifier. Elsewhere in our code, we're going to use that identifier. It's easier to remember a variable called first name or letter or age or something like that than trying to remember a much longer memory address. If you've only got 1 gigabyte of RAM in your computer, you've still got 1 billion different locations in memory. The second thing we set in a declaration is the data type. What kind of value are we going to place into that variable, for example? Now in Java, we've got two main data types. We've got primitive types and reference types. Now, we only need to know about 5 data types in AS Computer Science. There are more that exist in the Java programming language, and if you're interested in them, you can look at those in your own time. But 4 of the 5 we know as primitive types. Chars, ints, doubles, and booleans are built into the heart of the Java programming language. Strings, however, are reference types. You'll notice that string starts with a capital letter. It's a little bit more powerful than char, for example. Char is designed to store one keyboard character, such as a letter, a number, a symbol, that kind of thing. But string actually stores a sequence of characters. When we look at the idea of a primitive type, we first of all need to be aware of what kind of data is stored in each. So as I just mentioned, a char stores one keyboard character. You can type it on your keyboard, even something that's non-printing like a spacebar, that can be stored in char. But we can only ever store one value in there. It can be overwritten if it was a variable, but it's still only one keyboard character. The two numeric values we need to be aware of are ints and doubles. Int is short for integer. It's a numeric value, so therefore we could use it in a mathematical expression, for example, but there are no decimal places. Doubles take up twice the amount of memory than ints. One reason is that a double is a numeric value that might not have a decimal place, but potentially it can have either one or more decimal places. And it does require more storage in our computer's memory, or RAM, compared to the integer that simply cannot have a decimal place at all. It just doesn't recognize it. The final primitive data type is a Boolean. So these are named after a famous mathematician called George Boole. And he developed the idea of Boolean logic, which actually modern day electronics use. And this whole idea of binary and electronics running on logic gates and switches is down to George Boole's ideas. A Boolean value can store one of two values only. It's either going to be true or false. And as you write more programs in Java, or if you've written them in other languages, you'll see that the Boolean data type is a really, really handy one that we can develop quite sophisticated algorithms with. Now, if you imagine that when we create a variable declaration, it's a bit like, if we take the analogy of we're creating a box. This is a place in our computer's memory that's going to store a value. In our declaration, we're going to give that box an identifier, in this case letter. And into that box, we're going to assign a value. So if this was char letter, I might then, either in the same line, char letter equals A, or char letter, and then later on in my program, letter equals A. Whatever is inside the box is the actual value that we're wanting to store, provided that value matches the data type of letter, whatever our variable's data type is. Now, in contrast, we have reference types. The main reference type that we use in AS is the string data type. Now, notice that string starts with a capital S. All the other data types are just written entirely in lowercase letters. And there's a reason for that. Behind the scenes, there's more things happening with strings. A string is actually made up of another primitive data type, the char. So if you think about it, string is for text. What's text? It's a sequence of one or more characters. So at the basic level, the primitive data type char contains one keyboard character. But if we take a sequence of those keyboard characters to create a word, a sentence, a paragraph, an essay, that kind of thing, we actually have a string. If we take the analogy of the box, we've created a string data type. In this case, maybe I've called it my declaration string message. But instead of storing the actual value of that string inside the box, because this is a reference type, behind the scenes to the Java compiler, it's actually storing the memory location or the memory address of where the data is stored. Now this has some important consequences that I won't go into just at the moment, but if you get any problems in your code and you've got multiple string variables, this could be one of the issues, that you're treating a string as if it was a primitive data type rather than a reference data type. It's about what's stored in the box. Is it the actual value? That's a primitive data type. Letter, the box contained the value A. Or is it a reference type, message? The string variable message actually contains the memory address of the location where the actual text of that string is stored.